All right, we got some quick notes here on graphing. Graphing is going to be an important skill we use during physical science, and you'll probably use in a lot of schooling going forward, whether it's math, you'll have a science class like chemistry and physics, you'll probably do a lot of graphing. You may do some in some other science as well, like even biology or science, things like that. So, quick skill that we need to be able to do. And really the first question we have is like, what is a graph? And a graph is really just a way of presenting visual information. It's a visual display of information. So it's a way that we can pack a lot of information into a small amount of space and do it visually. Makes it very easy. Now there's different types of graphs that you need to be familiar with and be able to create. Really three primary graphs we'll talk about, and there's variations of these graphs, but three primary graphs that you need to be aware of. The first is a line graph, and a line graph, these are used to show trends or how data changes over time. So if you're looking at a graph and one of your variables is time, then there's a good chance you're going to be making a line graph for that. Now there's variations. There's line graphs where all the data points are connected, like you see on the left-hand side. And this is generally what we use when we have a single set of data. Like if I'm seeing how far I traveled on my way into work over a unit of time, or I would have that. So single trip. So I went to this place, and my data changes. It's a single trip. That alone is what's being utilized. On the other hand, if I was looking at average data, like I made 30 trips, and on average it took me this long, and then my next trip after 10 minutes I was this far. Each time I'm looking at every 10-minute increments how far I've gone on average. Since it's an average set of data, it's not just from one trip, then I do what we call a line of best fit graph. And you plot the individual data points like you see on the right hand side, and then you make a single straight line that gets as close as possible to all of those data points. This year we're not going to worry about like mathematically laying this line, but it is actually mathematically calculated, and in some of your math classes you might do this using a graphing calculator. We're just going to eyeball it here in physical science. Now sometimes we will use a line of best fit graph in places other than a set of average data. We might also use a line of best fit graph if we're looking at a general trend about what generally happens as opposed to a specific incident. So these are two line graphs, and then you might see in math classes that a scatter plot graph, which is essentially a line of best fit graph without the line of best fit laid. But those are some variations of line graphs. We're going to be doing both of those a fair amount this year. These will probably be the most popular ones that we look at are going to be line graphs. And some will be line of best fit, some will be a regular line graph. Those are your two different types. Now the next type of graph we need to know about is a bar graph. And a bar graph, these are usually used with the purpose of comparing information that you collect by counting. So you have categories, not numerical values. Like in this case, it's a number of goals scored by different hockey players. These are not a numerical value. You can't say that the hockey players are getting greater, more significant, whatever the case may be, as you go from the right-hand side of this x-axis. They're just different categories. It doesn't matter what order these gentlemen will be placed in. So this is where you're going to use a bar graph. These are probably what you're most comfortable with at this point, but really not going to be utilized a lot this year. But it is just another way to present information. The next type of graph is called a circle graph or a pie chart or a pie graph. It has a couple of names that people go by. And this is a type of graph that is used to show parts of a whole or how a fixed quantity is broken into pieces. And it's almost always shown as a percentage, where if you add up all the numbers, you'll end up with 100%. So in this case, it's like it's a favorite types of music graph. So 25% of people said their favorite type of music, and I go over here to this chart here. Up the green is country. So 25% said country music, and 11% said rap. So these are just percentages, and if you add all these up, they should equal 100%. And if they don't equal 100%, then something is wrong or something's missing. So that's a circle or a pie graph. Again, not one we're going to be using a lot this year. Again, I'll say the ones that we're going to be using the most are going to be these line graphs or line of best fit graphs. So with that in mind, we're going to talk about the steps for drawing a line of best fit graph or a line graph. Largely, it's also used in a bar graph, but I'll talk about it kind of in terms of a line graph. The first thing we need to do is identify our independent and our dependent variables. Now, our independent variable, the IV, that's what I as the experimenter control. The DV, the dependent variable, depends on the variable that I control. So the independent variable is what goes on the x-axis, and the dependent variable goes on the y-axis, or the axis that runs up and down. A lot of times, we don't think about us as controlling time, but a lot of experiments that we do, we're controlling that a measurement was taken every 5 minutes or every 10 minutes or every 30 minutes. So that's when the measurement was taken, we're controlling. So if we're doing a change over time, time is normally going to be our x-axis. Again, time, the x-axis is the variable that we control as the experimenter. It's the independent variable. So after you do that, you label these axes, you identify which is which, what's my independent variable, you write it down, what's my dependent variable, you write it down. This is also a good time or place to identify what is the unit you're measuring in. So this would be like time in months, average temperature in degrees Celsius. So you're specifying what the unit is that goes along with these labels. Now you've got your x and y axes labeled. Now you're looking at, okay, am I going to make a bar graph? Am I going to make a line graph? You make that determination. And then you, assuming it's going to be a line graph, you need to go and mark off your x-axis. This means that you're looking at your graph paper, and every block on the graph paper needs to have the same value. So like this block here has a value of 2, and then the next block also has a value of 2. It always needs to be the same. The next block also needs to be a value of 2. The next block also needs to be a value of 2. So it always needs to be a consistent value on the distance traveled along the x-axis. So you don't have like, oh, a data point at 2, and then, oh, my next data point is going to be at 10, so I'm just going to make my next line 10. You can't do that. Every block on the graph, on the graph paper needs to be the same value in terms of magnitude of the variable. That also has to be the case with the y-axis, although the magnitude of the value of the block for the y-axis can be different from the x-axis. Every block on the y-axis must be the same. So again, in this case, each block on the x-axis has a value of 2, but each block on the y-axis has a value of 4. So you're just counting up. The first line is 4, the next line is 8, then 12, 16, 20, and so on. On the x-axis, it's 2, 4, 6, 8, 10, and so on. So those values remain consistent. You mark them off, number them. You don't need to number every single line. Sometimes that becomes too cluttered. You maybe want to just number every other line. So instead of putting this 2, you go, all right, that's 2, and then 4. I'm going to number 4 here. Then that's going to be 6, and this is 8. I'm going to write the number 8 there. So you don't need to write the value of every single line now. They just need to be consistent. So you do that. You've already labeled your axes. You've written the numbers down for your axes. You've written the unit for what the axes are, and now you're really set to go. So you can do all that with the x-axis, then repeat all those steps with the y-axis. First you label, write your unit down, identify whether it's going to be a bar graph or a line graph. If it's going to be a line graph especially, you then number your x-axis, making sure that each block has the same value. Then repeat all those steps for the y-axis. At that point, the next thing you're going to do is plot your data points. So you're going to look at your graph here. I've listed my name and my unit for my x-axis. I've listed my name and my unit for my y-axis. I've numbered my x-axis, I numbered my y-axis, and now I need to plot data points. And oh, the student that studied for 5 minutes got a score of 70 on their test. So that'd be right here. Now I put a dot. I also suggest you put a little circle around the dot. That way you know it's not a straight mark. And then the student that studied for 10 minutes, they got a 80%. So we put their data point, circle it, Student studied for 15 minutes. Oh, this student must have had an off day because they only got a 75%. So they dropped a little bit. But the student who studied for 20 minutes got 95%. So I'm just plotting my data on here. Student studied for 25 minutes. They got a 96%. The student that studied for half an hour got a 99%. So I plotted my data, and I'm noticing, in general, the more time that was studied, the higher the grade was. So that's going to be a trend that as time went on, as more time was spent studying, the grade increased. No, it wasn't perfect because this student studied longer than the previous student, but didn't do as well. Now, assuming this was average data, I studied 100 kids with 6 times here, so I had 4 or 5 students, say, at each time duration. It's average data. It's also showing a general trend. So now I'm going to go and I'm going to make a line of best fit, and I'm going to show that my data in general went like that. That's what my data in general did. A nice straight line. It goes near my data points but doesn't necessarily touch them. So that's making my line graph. The last thing I need to do is title my graph. And a good way to title a graph, kind of a general rule of thumb that always works, is to take your problem and just eliminate the what is. Remember, we have a specific format for problem. It's what is the effect of our independent variable on our dependent variable. If you eliminate the what is at the beginning, you just say the effect of, and I have time studied. That's my independent variable. So time studied, or time studying, on, then my dependent variable, grade on science test. There's my title. The effect of time studying on grade on the science test. That is a good way to title. And notice there's no pronouns in the title. So no I, they, we, he, it, anything like that. That's a great way to come up with a title. Sometimes you need to modify that a little bit and say, like, the effect of time studying on grade on the science test for Mr. Stoneback's B7 class. It's just you need to sometimes add a little modifier on there at the end, but that's a good way to come up with a title for your graph. So if you go through those steps, you're good, and you'll have a good graph. This year, when we do graphs are going to be a pretty large portion of the grade that you're going to have on things like labs. So it is a skill you want to make sure you have, so please come back and review this video whenever you need. I hope that helps you out. Have a good one.